Hello everyone, I'm going to briefly review the modeling overview for you. So modeling is a way that we represent these ideas with simplified versions. Okay? And this model, and you can remember, click on these to get definition of words. This model gives you different ways to think about and communicate designs and ideas. We remove some of the complex elements to simplify it. And a model is just this simplification or this abstraction of what it represents. So these models all have limitations. Many times you create a model because the real thing may be difficult or expensive or it's not even real yet. And many times you don't even need the real thing to achieve your goal. You don't need a real bike to instruct someone how to put the bike together. You can use a visual model, the drawings. So we understand that the bike parts stand in for the actual parts, but it doesn't have this 3D form. So it doesn't function like a bike, but the model serves the purpose that it's needed. Scientists and students like y'all use models to help visualize things that they can't see. You don't need a real water molecule to explain and demonstrate how the atomic structure is done. A schematic or physical model will do the job. So you see several different models for water right here. But no model is going to behave like a water molecule. However, even though there are limitations, you can use these type of things to communicate your process. So, understanding the purpose and limitations of your model is the key to choosing the one you're going to use and to understanding the ones that you use. For us, our models generally help define problems, communicate ideas, and test designs and predictions. So there are many types of models used. So figure 2 is going to show the different types here, and we often use more than one type. So we have the graphical model, used for help fleshing out ideas, 3D models like CAD, circuit schematics, graphical diagrams, that type of thing. A prototype model is a physical object. It's a proof of concept. It may be a virtual, it may be a simulation. It doesn't have to work. Sometimes the prototype model is just used to show things. You have the mathematical model, represented by math. Analysis, testing, it helps perform the design. It helps you analyze things and predictions. And then you have a conceptual model. This is where a lot of our brainstorming and pre-done stuff comes from. Just ideas, sketches, annotations, specifications. So these are 4 types of models that we're going to use, that we've been using, and kind of what category they fall under. So generally, we've started by creating our conceptual models representing our brainstormed ideas. As we take that conceptual model and turn it into something better, we've refined it to show design details and technical specifications. We have a graphical model. And this graphical model is used to produce a virtual or physical working model, such as what you printed out, the prototype. The prototype is usually used to test some parts of the design to compare performance. It does not necessarily have to test every part of the design. For a complex part, you can prototype smaller processes to test those individual processes. Other types of things that we use are mathematical models, and all of these can be used together. But the mathematical model is especially important because it represents our assignments, our projects, our designs quantitatively using numbers. All right. Generally, if you don't involve applying mathematics to a solution, it's not engineering. All right. Engineering is applying science and math to problem solve. So to choose a model, you need to think about the type that will accomplish the goal of what you're attempting to do with the least amount of resources, such as time, materials, all that. Whether you need to communicate ideas, record them, compare options, test things, all of those have different types of models for different uses. Generally, prototypes are the most expensive. But if you can use a less expensive and easily processed material, you can save money. You may trade accuracy in prototyping and performance to save money. But what's important here is that you need to carefully select the models that you use to accomplish specific purposes, and you need to acknowledge the limitations of these models. All right? So for this assignment, you've used a number of these models. In this situation, rather than picking out the type of model you're going to use, I would like you to go back and look at all the types of things that you have done and basically identify what type of model you used in each step of this process. So identify the type of model, try to think about some of the limitations of it. Let's go back to the submission document real quick. What type of model? Why did you use it? What were the limitations? Why should you have used it this time versus some others? So those are the things I want to identify with this model.